This is a video on section 2.8. I intend to make 2 videos in this section, and this is going to be the first one. What I want to talk about first of all is simply operations with 2 or more functions. So you'll notice that what we're going to be looking at here is adding, subtracting, multiplying, and dividing 2 different functions. What I want to show you in this particular gray box here is that these 4 methods are going to be the best way to write in your work these functions, the adding and the subtracting, the multiplying and the dividing, and you'll see me model that as we go through. We'll discuss domains as we go through as well. The one major thing to discuss here is that you're not allowed to have a 0 on bottom. We already know that. We've talked about that in prior sections, but it's just a reiteration that is something that we're going to be on the watch out for. All right, let's just jump right into some examples here. And you'll notice that for 4 examples, I'm supposed to add, subtract, multiply, divide. And the first thing that I'm going to do with part A is I'm going to write it in the method that I just got finished showing you is the best method. This one right here, where I'm looking at f plus g of x and turning it into f of x plus g of x. But this time I'm told what my x value is. I'm told that my x value is 0. So I'm going to write f of 0 plus g of 0. We all know how to find f of 0. All we need to do is take 0 and plug it in for all of the x's in the f function. So it looks like that, and I do keep it separated by a set of brackets. And then the second thing we're going to do is take our g function and plug 0 in for all of the x values there. And then we'll just simply, and by the way, if you haven't figured this out, the f function and the g function came from this particular line up here. Just a quick note about that. You may have something else here. Just check your notes and make sure that you also have this. And if not, go ahead and edit your notes according to what you're given. I did catch some mistakes on the original set of notes that I had. So now we're going to follow the order of operations. So we're going to multiply and subtract here in our first group, and we'll do powers, multiplying and subtracting in our second group. So multiplying, you get 0 minus 4, which is negative 4. And then here, 0 squared is 0 times 2 is 0 minus 1. And then you just simply combine like terms, so you have a negative 5. All right, let's go over to part B. Same f and g function. I'll hide that a little bit though. And so the first thing I want to do is just simply write it in a way that's easier to understand. And then I will plug a 4 into my f function. So once again, here's my f function. Let's plug a 4 into that. And then we'll plug a 4 into our g function. And now we're just simply going to do the math. So here you have 3 times 4, which is 12, 12 minus 4. And then over here on this one, 4 squared, doing powers first, 4 squared is 16. Then multiplication next, so 16 times 2 is 32. And then you want to subtract your 1. And then we will continue to work in the groups. So 12 minus 4 being the 8. And the other group is going to be that 32 minus 1 that I already mentioned. 32 minus 1 is 31. Combine your like terms, you have a negative 23. All right, let's go over to part C. Do the same thing, only now we're multiplying. So we'll have an f of negative 2 times g of negative 2. So once again, using those equations that we have up at the top, f of negative 2 is going to be 3 times negative 2 minus 4. G of negative 2, plug that negative 2 in. And now let's do the work. Now I did a lot less work on this one, so walking through that really quickly, this is going to be a negative 6 and a negative 4. And this one is going to be, again, use your power first, so that's going to be a 4, times your 2, which is 8, 8 minus 1. And a negative 10 times a 7 is going to be a negative 70. All right, last but not least, let's talk about division. So we have f of 3 divided by g of 3. So on top, f of 3 is going to be 3 times 3 minus 4 using those original equations. On bottom, G of 3 is 2 times 3 squared, or 9 minus 1. So we'll have on top 9 minus 4. On bottom, 18, because that 9 times 2 becomes an 18 minus 1, which is going to reduce then to 5/17, or not reduce, but simplify. All right, now let's go on the more generic side. So this one, I'm pretty certain your notes are not going to be the same. So if you would do me a favor, go ahead and pause the video and change these two equations so that we're going to be looking at the same thing. And that will, it'll give us a little bit better practice, I think, than the ones that I originally had in the notes. Notice that we're doing two things. First of all, I'm asked to find each of the following. And then secondly, I'm asked to give the domain of each of those in parts A through D. And there's something else that's different here as well. Notice that this doesn't say f plus g of, like a 3. This says f plus g of x. So we would say that what we're doing is we're finding a generic new function as opposed to something specific. All of these up here were specific new functions because we were plugging in actual numbers. Here we're not plugging in actual numbers. All right, so let's just start on this then. First thing is let's write it in that nicer way, f of x plus g of x. And we know what f of x is. We've been told what it is. So f of x is 2x minus 1. We're going to add to that g of x, which is 4 over x minus 1. All right, now you guys know that in order to add fractions, you need to get a common denominator. So the first thing I'm going to do, this is just a copy of what I already had. But I noticed that this particular term, this group, needs to have the same denominator that this has. So I'm going to multiply by that common denominator on top and on bottom. So then what we'll have on the bottom, let's see if I'm erasing the right thing. Yeah, on the bottom, I have that common denominator x minus 1. On the top, what we'll want to do here is we need to FOIL. And then you'll notice at the very end is that same old plus 4 that I already had. Okay, so these first three terms, this is my foiling simplified. And then we'll combine like terms, which is only the last two terms, and keep my common denominator. All right, now let's stop right here and let's talk about domain. You'll remember from section 2.6, 2.3, section 2.3, where we learned how to get the domain when I don't have a picture. And remember that we said that generically, all domains mostly are going to be all real numbers, but there's two cases when it's not going to be real numbers. One of those cases is when we're dividing by 0, and the other case is when we have a square root. So we ask ourselves, is there anything in any of the work where I could have a 0 on bottom? Anything at all where I could have a 0 on bottom? And I say, yeah, absolutely. I could have a 0 on bottom here, and here, and here, and here, and here. Now, they all happen to be the same denominator. They're not different. So what you'll remember, and I'm going to go down here, and I'm going to actually show some work over to the side here. What you'll remember is that back in section 2.3, we took our denominator, which was x minus 1 in this case, just making sure I remember that, and we set it not equal to 0, and then we solved. And so we said that x cannot equal 1, because we're going to add 1 to both sides. So for part A then, what we've got is that our domain is x is not allowed to equal 1, and I went ahead and just simply wrote it in step builder notation. If you're asked to put it in interval form, you'll need to put it in interval form. All right, let's go to part B. So part B, this time we're subtracting, so we have f of x minus g of x. F of x is our 2x minus 1 minus g of x. Go ahead and plug that one in. All right, so once again, we'll notice that I'm trying to subtract fractions, so I need a common denominator. So this is just a copy of what I already have. I'm going to multiply, just like I did on part A, by that common denominator over itself. And so on top, I'll FOIL. Go ahead and subtract that 4. And then on bottom, I have my common denominator that I just write. Combine like terms on top, keep the denominator. Once again, I go to all of the whole entire question, all of the work, not just the final answer, but all of the work, and ask myself, is there any place that I could have had a 0 on bottom? And absolutely. And these all happen to be the same as part A. And so I don't have to redo the work on that. For part B, my domain is just going to be, once again, that my x is not allowed to equal 1. All right, let's go to part C, the multiplication. So we're going to take f of x times g of x. So we'll multiply. Remember, with multiplying fractions, this is actually over 1. And so you just multiply the tops and you multiply the bottoms. So when I multiply the tops, I could say, hey, this is in factored form 4 times the quantity 2x minus 1, which is what I have here. Or you could also distribute and have an 8x minus 4. Either of those, folks, is simplified. And then the denominator is just x minus 1. Once again, I asked myself about domain. All of the work has the same denominator over and over and over again. So my domain then is going to be, once again, x is not allowed to equal 1. All right, last but not least, on this particular example is going to be the division question. So we take our f of x, we're going to divide our g of x. So our f of x we know is 2x minus 1. Our g of x is 4 over x minus 1. Okay, you remember how to divide fractions. When you divide fractions, you need to multiply by the reciprocal. Keep the top. Okay, so that's what I have here. But the bottom, you're going to flip it over and multiply. Okay, so you can see that that's the reciprocal of the denominator. So now I'm going to go back to, let's multiply tops and multiply bottoms. When I multiply tops, and this is done by foiling, I'll have 2x squared minus 3x plus 1. And then when I multiply the bottoms, I have a 1 times a 4. Here is especially where I want you to pay attention. If I only got the domain on this answer, there is nothing that's going to make the bottom 0. But that's why I say you have to make sure that you look at all of the work in the entire question. Is there any place in the work that could cause a domain or could cause a 0 on bottom? That's going to affect the domain. So once again, yeah, this guy here it could be a 0 on bottom. It happens to be the same as it was for the other 3. So once again, x is not allowed to equal 1. All right, so let's go ahead then to our next example. And this is the same type of idea, add, subtract, multiply, divide. The difference is that now I'm either using a graph or I'm using a table. All right, so I'm going to hide, let's see, yeah, I'm going to have to. I'll hide these things, so just pay attention to what they're saying. These 4 things that I'm supposed to find, the add, subtract, multiply, divide. And we'll go through them one at a time. So on this first one, we are asked to add f of 1 plus g of 1. Now, the f function is, notice it's right here. This is the f function, okay? And the g function is this one up here. So this absolute value graph is going to be my g function. So let's go to the f function and find f of 1. Well, 1 is the x value. So here's the x value. What is the y value on the f function? Well, the y value is going to land right here. And so that's going to be a value of 3. Okay, well, then let's go to the g function and let's find g of 1. So we're going to that exact same x value there at 1, only now on the g function, that one's right there. And so that gives me a y value of 1. So when I plug in the y value of 1 and add, I get 4. All right, let's go down below. I don't remember actually if this one next is the subtraction or the addition, but we'll go down below. And what we have here, let's uncover it. Yes, it's the subtraction one. So we want to subtract f of 0 minus g of 0. So once again, let's find the x value of 0, which is right here. And I want f of 0, where f of 0, what is the y value on the f function? Well, that's going to be a value of 4 on the f function. So I've got a 4. Oh, just gave that one away. So the g at 0, whoops, is once again going to be, here's the x value of 0, but the g function is at the same place, so the y value is also 0. And we have to do 4 minus 0, and we'll get 4. All right, now for the multiplying. So for the multiplying, we're doing f of -1 times g of -1. So f of -1, all right, here we go. Here's the x value of -1. Here's the y value. So the y value on the f function is going to be 3. G of -1 is going to be 1. So we have a 3 times a 1, which is a 3. Last but not least, let's go to the division. So for division, we're doing f of -2 divided by g of -2. Well, first of all, f of -2 is this guy right here. That's the x value of -2. What's the y value on that f function? Well, it's going to be 0. On the bottom, g of -2. So once again, if we find our g value, here's -2 x value, g is right here. And so that value is going to be a 2. So the g value, the y value on the g function is 2. 0 divided by 2 is 0. And then we have one that is the same concept, only it's a chart instead of a graph. So the same 4 functions, still the f plus g of 1 and all that. Okay, so go through them one at a time. So first of all, f of 1 plus g of 1. So find the x value of 1. Well, here's the x value of 1 because these are all x values. Well, f of 1 is going to be 1. G of 1 is going to be 6. Add, you get 7. All right, let's go to the subtraction. So the subtraction is going to be f of 0 minus g of 0. By the way, at this point, you're probably getting the hang of this. You could very easily pause the video, do the other 3, and then check your work and see if you get them right. So f of 0, I'm going to be looking here at this line. F of 0 is -1. G of 0 is 4. So f of 0 is -1. Bring down your minus sign. G of 0 is 4. And you have -5. Go to multiplying. So this time we are taking f of -1 times g of -1. So now this is the line we're looking at. F of -1 is -3. We're going to multiply by g of -1, which is 2. And -3 times 2 is -6. And the last one, we have division. F of -2 divided by g of -2. So come back. Here's what we want to look at. So f of -2 is -5. G of -2 is 0. Oh, wait a second. We're not allowed to divide by 0. So you could say that this is undefined, or you could use the symbol for the null set. Okay, and the way you spell null, the null set. Okay, they're the same thing. All right, one more of these. And once again, I can't show these at the same time, but these are the same 4 questions that were being asked for part C. The difference now is that I have 2 equations. All right, so first one, f of 1 plus g of 1. So let's go ahead and plug in 1 to our f function. Then we'll plug in 1 to our g function. Work your order of operations. So groups go first. Multiplying comes before adding. 7 minus 1 is 6. For the subtraction one, f of 0 divided by g of 0. So f of 0, you can see is going to be plugging in 0 is going to end up being a 4. G of 0, absolute value of 0 with a negative out front. And so this is going to turn into a 4 minus 0, which is 4. For the multiplying, f of negative 1 times g of negative 1. So f of negative 1, plug that in. G of negative 1 is going to be the absolute value of negative 1. That first quantity is going to be a negative 3 plus 4, which is just going to be a 1. The second quantity, and don't forget you're multiplying here, the second quantity, what's inside the group first, the absolute value, this is just going to be a plain old 1. So that's where I get a negative plain old 1. And 1 times negative 1 is negative 1. And then for my division, f of negative 2 divided by g of negative 2. Plug in your negative 2 on top. Plug in your negative 2 on bottom. Clean it up. So up on top, a negative 6 plus 4 will give you a negative 2 on bottom. Again, work your order. The group first, so that's going to be the absolute value of negative 2 is just a 2. And so you'll have a negative 2. Divide, and you get 1. All right, there's one more that I want to do, and this one's sort of an extra type question, and it's prepping you for eventually going into calculus. So I'll move through this one pretty quickly, but take a look. This one's a little bit crazy. What you're being asked to do is you're asked to take this function, and you want to use this statement, which is called the difference quotient, and apply it to our function. Now, so let's look at what we're going to do first. The first thing we want is to find out what is f of x plus h. We already know what f of x is. We were told. It was handed to us. But what is f of x plus h? So I've done this over on the side here. So f of x plus h is where I take x plus h and plug it in for every single x that's in my original function. So you notice I have 3. This x came out, and now it's being replaced with an x plus h, and I'm going to square it. And then for the next piece, I'm going to have a minus 2 times x plus h. And then lastly, just a plus 4. There's nothing to plug in there. Now, the rest of what I'm going to show you is just the cleanup of this. So I want to FOIL, and then after I FOIL, I'll distribute. Okay. So there's the foiling. This piece here, this is where I distributed the negative 2. And then last but not least, we'll combine any like terms that we might have. Distribution and combining like terms. So then that means that f of x plus h is this big old long thing. Okay. But that's nice because now that I know what f of x plus h is, I can take it and I can plug it in for this guy. So that's exactly what I'm going to do first. I'm not going to do any math except for I'm going to plug in what I just found for what's circled right now. So let's go over to the right side of the page. And the first thing I'm going to do is just simply plug in what I found over here. Then notice that I'm going to subtract my original function. That's this guy right here. So we want to subtract the original function. And then I'm going to put that over h. So there's definitely no work involved in that. Now what's next is just going to be combining like terms. What I didn't even combine like terms. All I did was rewrite it without that minus sign. I took my minus sign and I distributed it. Sorry, that's hard to say. To all 3 terms here. So that's all that you see in this next step is that I was just distributing the negative. Now I'm going to combine my like terms. And you'll notice here that I have a 3x squared and a negative 3x squared. They're going to zero each other out. I also have a positive 2x and a negative 2x. They will zero each other out. And I have a positive 4 and a negative 4 that will zero each other out. So now what I'm going to do is just simply write down all that's left over. Now I want you to notice something. In the leftovers, all three of the terms on top have an h in them. So I have a GCF of h. So I'm going to factor the h out of each of those three terms. And once I do that, then I can cancel the h on top and the h on bottom, so that now all that's left over is 6x plus 3h minus 2. This is a great exercise, and it's not only useful just for calculus, but it's a great exercise just to make sure you completely understand the concept of plugging something in that's not just a nice, pretty number.